This is Mr. Anderson for Math 121, the first section of Chapter 6, Multiplying and Dividing Rational Expressions. We're going to be looking at, in the first part of our two-part video here, we're going to be looking at multiplying rational expressions and doing some simplification. A lot of us do simplification pretty well and are easy to see that these two do simplify to make an expression of x plus 3. And this is because we have an exact match of our monomials. See, our monomials, or the binomials, and in this case trinomials too, must match. And if they don't, you cannot simplify them. For example, in this problem, you cannot cross out the x's. This is an illegal cancellation. As this is also illegal as well. Even though you might say, well, I have a match where the x, x plus 3 and x plus 3, they're matching binomials. This is not a legal move. So you may want to also check your book on page 356 to take a look at some other illegal moves or operations. So down here, you can't cancel out the x's, nor could you do that here, but that's really not the point. The point of these first four problems is to find excluded values. As we did in the previous chapters, we looked at when our x is going to be equal to 0. And remember, if you take any number, any number and divide it by 0, that is undefined. And we must exclude these values from our answer even when we're simplifying the problem. And normally in the book these are going to be listed as f of x is equal to 0, and we're finding the values of x that would cause a 0 in the denominator. So what you would do is you're going to set the denominator equal to 0 to solve for when the danger number is. And I usually put a cross through my equal sign because if I do that, then I have my answer already done for me. X is not equal to 0 in this case. Or in this case, x minus 5 is not equal to 0. And if I move the 5 over, my x cannot be equal to 5. So if I plug 5 into the denominator, that would give me a 0. In factored forms, things are kind of nice because I can take my x plus 3 and set that not equal to 0. I can also take my x minus 4 and set that not equal to 0 and get my two excluded values this way, negative 3 and positive 4. These are the two values that if I plug this in for my denominator, that will give me 0, which is an undefined answer. The numerator is completely superfluous here. We don't actually look at that for our undefined answers. So when we get to this problem here, we just need to figure out the number in the denominator that will give me 0. And I will set my 2x minus 3 not equal to 0, move my 3 over, and then divide by 2. So my danger number is going to be 3/2 or positive 1.5. If I plug 1.5 in for my x, then I get 3 minus 3 and my denominator would be 0. So we're going to be finding these excluded values at the beginning of each of these problems, and that will stick with us through the end of the answer. So let's go and take a look here in problem number 5. First of all, we're going to try to see, is there a number that we can plug in for x to give me a 0? And that's true. The denominator here has just an x in the monomial, so therefore my x cannot be equal to 0, because x to the 7th power, 0 to the 7th power is 0. 6 times 0 is 0. There's my danger number. But in terms of simplifying, 18 and 6 becomes basically dividing top and bottom by 6. This is 3 over 1. And then x cubed over x to the 7th, this leaves me with 4 x's in my denominator. If I'm using that principle of taking 3 minus 7, gives me negative 4, or 4 in the denominator. So my final answer is 3 over x to the 4th, such that my x cannot be equal to 0. And there's your answer. Looking here, to find my excluded values, I'm going to first take my denominator, 15x minus 25, and set that not equal to 0. Moving the 25 to the other side, that gives me 25. And then I divide both sides by 15. X cannot be 25/15, which is reducible down to 5/3. So this is my excluded value, x is not equal to 5/3. But I can actually go to the problem here and I can simplify by factoring out a 5, which is x plus 2. And simplify here by factoring out a 5 as well. x minus 5. The 5 simplify, which leaves me with, oops, that should be a 3x minus 5, which leaves me with x plus 2 over 3x minus 5. And this is my answer for the problem number 6. My excluded answers are easy to see. If I set those equal to 0, I won't work through all the problem there, but those are my 2 excluded answers. This numerator can be simplified if I factor out a 2. And then I can crisscross the binomial since they're perfect matches, which leaves me with 2 over x minus 4. And my excluded values are right here. For problem number 18, to look at my denominator here, 2x minus 8, if you think mentally 2 times what number minus 8 is 0, then you come up with your excluded value, x cannot be equal to negative 4. Oh, not negative 4, positive 4 in this case. Sorry about that. So x cannot be equal to positive 4 because 2 times 4 minus 8 is 0. Now this numerator can be split into x plus 4, x minus 4 through factoring. And my denominator, factor out of 2, x minus 4. The x minus 4's go away, x plus 4 is in the numerator, 2 is in the denominator, and my x cannot be equal to 4. Now you'll notice that in our denominator here, there really is no problem, but since the start of the problem, if there is an x in the denominator, we have to include that in our excluded values. Just because it simplifies out of the denominator doesn't mean we can get rid of the exclusions we had in the beginning. Let's do some factoring before we find our excluded values here. X plus 3, x minus 3, and then down below we're going to have x minus 3, x minus 3. We're going to do some crisscross simplification here. So, well, before we do, let's do our excluded values. X cannot be equal to positive 3. If I plug that into either of the denominators, that's going to give me a 0 in the denominator. Let's do some simplification now. We can simplify these two. So I got x plus 3, x minus 3. But a quick question. Can we cancel out the x's? No. Can we cancel out the 3's? No. We can't cancel out either of those because they are not perfect binomials being the same. For problem number 10, let's take a look at this here. We're going to find our excluded values after we do a little bit of factoring. This is going to be x minus 4, x plus 1. That is the two numbers that multiply to make negative 4 and add to make negative 3. Now, when you, whoops, that should be a 1 there. When you do any kind of problem in the book, you'll notice that sometimes you have to factor again, but one of your two answers is probably going to be something from above here. And it actually works in this way. The two numbers that multiply to make negative 8 and add to make negative 2 is x minus 4, x plus 2. So excluded values, x cannot be equal to positive 4 and negative 2. And we do some simplification, and our answer is x plus 1 over x plus 2. We cannot cancel the x's here because they're not monomials, they're part of the binomial, and the binomials have to be exactly the same. Okay, moving on to problems 11 and 12. I have a little rhyme here to help you a little bit with multiplying fractions. Multiplying fractions, not a problem. Top times top, bottom times bottom. And what's nice about top times top, bottom times bottom, is that it will allow us to take this expression and put it together as if they are, all over one line, and the binomials are now in parentheses. And we can do some massive simplification, but first we should check our excluded values. In this first problem, can you think of a number multiplied by 4 to give you 8? And that way, that would give you 0 inside here. And the x value that would do that would be a positive 2. So x cannot be equal to 2, or x cannot be equal to 0, because 10 times 0 is 0. And if you have a 0 in your denominator multiplied by another number, you're going to have 0, and that will give you an undefined answer. So let's do some simplification. First of all, the 5 and the 10, I can make that 1 and 2. The x cubed and the x, I can make that x squared. So that leaves me with x squared in my numerator. I can factor out a 6 here, so I'm going to multiply that by 6, and which gives me x minus 2, all over. I'm going to factor out a 4 here, which leaves me x minus 2 times, and the 2 down here below is still there. So this leaves me to cross this out and this out. The 6 can be divided by 2, so the 6 becomes a 3 and the 2 becomes a 1. So my numerator is 3x squared and my denominator is 4. And that's my final answer with the excluded values of 2 and 0. For problem 12, we've got a lot of factoring to do, but we'll get our excluded answers after we do our factoring. This x squared minus 9 is going to be x plus 3, x minus 3, using difference of squares. The x squared minus 3x, let's factor out a x, which gives me x minus 3. And then down below here we have x squared. And over here we have x squared, well, I'm sorry, two numbers that multiply to make negative 6 and add to make negative 1. That's going to be x, sorry about the little square there, x minus 3 and x plus 2. So let's see what our excluded values are. Well, x squared means x cannot be equal to 0, or x minus 3 means x cannot be equal to positive 3, because 3 minus 3 is 0, and negative 2 is our third excluded answer, because we have negative 2 plus 2 is 0. Let's do some cancellation or simplification. The x minus 3's go away, and that leaves my numerator, well, wait a second, I've got an x and an x squared, so I cross out the x and make this down to x to the first power. So my numerator is going to be x plus 3, x minus 3. No need to FOIL that back into difference of squares. And then we have x times a quantity of x plus 2. There's no need to FOIL or distribute this into the back answer. This is going to be okay. And there we go. One more multiplication trick to end the video here on problem 13. And it's when you see the one of the two problems in the reverse order. And when you're going to see that a couple times in the homework, and I would strongly suggest that you pay close attention to it because you'll need to fix it. To fix it, you would need to factor out or multiply by negative 1 in the denominator. And what will happen is that the numerator will stay exactly the same, x minus 2, and the denominator will become negative 2 plus x, which I can write like this. Now remember, there's still a negative 1 that's actually factored out in the denominator. So what this means is that my numerator is now the same as my denominator, and these are binomials, so you can simplify those, leaving me with 1 over negative 1. See, then since those go away, I have this. Now what's important about this is do not leave your answer like this. 1 divided by negative 1 is negative 1. So when we look at a problem like 13, you should, do your factoring and your, factor out a 7, which makes x minus 2. Factor out a negative 1 to change this into x squared minus 4, which is the same as x plus 2, x minus 2. Flipping this around will give you a difference of squares, x squared minus 4, which is the same as this. Now, I'm going to do some scrap paperwork for this 5x squared plus 6x plus 1. Since it's a tricky trinomial, I'm going to kind of do it over here in this rectangle. A tricky trinomial, 5 times 1 is going to be 6. Oh, sorry, 5 times 1 is going to be 5, and the two numbers to multiply to make 6, or 5 and add to make 6, are going to be 1 and 5. So this changes the problem to 5x squared plus 5x plus 1x plus 1. Again, 5 times 1 is 5. The numbers that multiply to make 6x, or multiply to make 5x and add to make 6 are 5x and 1x. So now we do our factoring by groups. This is going to be 5x times x plus 1. Factor out a 1 here, x plus 1. So this expression here is 5x plus 1 and then x plus 1. And this is a review of chapter 5 section 4. If you got a little confused as to what I did there, please go review chapter 5 section 4 video on how to factor trinomials. So this is going to be in parentheses 5x plus 1 and then x plus 1. My denominator here, my 35x plus 7, this is going to be factoring out a 7, 5x plus 1. Now Now let's see what simplifies. 5x plus 1's go away. The 7's go away. And the x minus 2's go away. And remember, when I say go away, I mean they turn into 1. And technically we simplify that out. So what we have left is, in the numerator, x plus 1. In the denominator, x plus 2. But make sure that you still have the negative 1 somewhere, whether that's out in front of the problem or multiplied by the bottom or top binomial. So you have to have a negative somewhere in the problem, and you'll only have one because two negatives will make a positive. So there's your final answer. I didn't do any excluded values, but if I did from the original problem, my excluded values would be negative 2, positive 2, and negative 1/5. So just to put my excluded values from, now we take it from the beginning here, I'm just going to put them down, negative 2, positive 2, and negative 1/5. And you can set the 5x plus 1 or the 35x plus 7 not equal to 0 to see why it is going to be negative 1/5. Alright, now this is the end of the first video. Stay tuned for the second video as we look at dividing fractions and polynomials.